Today, I'll be joined by my former colleague Kevin, and we'll be working through a code challenge that you might see in a programming interview. And you'll get to hear our discussion as we go through what would be a very realistic interview situation, with the interviewer asking some helpful questions and Kevin going through solving the code challenge. First, we'll go through with a brute force approach, and then we'll come back with an optimized solution at the end. So sit back, relax, and enjoy this conversation with Kevin. Kevin, thank you for joining me. Today, we're going to be looking at some programming and doing just one of the leak code problems or that you might see in an interview just for practice purposes. So Kevin, thanks for joining me today.
Hey guys, how's everyone doing? Awesome. Thank you, Kylie, for having me.
Yeah. So
We're
what are we looking at here?
we're looking at this two-number sum. I just pulled this up, so I'm gonna go ahead and read it out. Right? It says write a function that takes in a non-empty array of distinct integers and an integer representing a target sum. If any two numbers in the input array sum up to the target sum, the function should return them in an array in any order. If two numbers sum up to the target sum, the function should return an empty array. Got it. Note the target sum has to be obtained by summing two different integers in the array. You can't add a single integer to itself in order to obtain the target sum. You can assume that there will always that there would be at most one pair of numbers summing up to the target sum. Cool. And this is, I guess, the sample array, and this is the target sum. Okay. So this is the problem we got here. I'm a little rusty here,
Yeah.
so this is like what you would probably see. It's an easy question, as what they categorize it. Might be a little more difficult for me, but yeah, let's dive in, right?
Now, I think a lot of these questions, even the easy, medium questions, it's not that they're easy or medium. I think a lot of the times it's like, do you recognize the pattern that you need to use here? Have you seen this before? And if you have, then you just implement it. If you haven't, I feel like even easy and medium questions can sometimes be, they could take you an hour to solve. And so if you're solving this in an interview and you have 30 minutes or less and you don't recognize it and you don't know the pattern, that's a pretty tricky situation to be in, whether it's easy or medium or hard. But this one, do you recognize the pattern? Does anything jump out to you as like, oh, this is one of those questions?
Uh, yeah, I don't know. I don't know about patterns, but I do feel like this is one of those questions where it's like you can eliminate sort of from the beginning without having to go through much of the array itself, if that makes sense.
Yeah. 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 So you're saying you wonder if we could maybe do this in O of n time,
Right.
like, yeah, without having to like go through the array over and over again.
Exactly. Because I think that that's what essentially we should do, right? In a brute force type of approach, you would want to go through each and every single element in the array, one after the others, to see if it sums up to the target sum, which in this case, in this example, would be 10.
Mhm.
But is there a faster way? And I guess in an interview, you would actually want to go the brute force approach first, right? And you would want to go and start asking questions, and you would want to start just like note taking down exactly your approach, and then optimize at the end.
Let's talk about that because, like, in an interview, I think it would be wise for you to kind of talk through the brute force approach, but not write any code, not write the brute force approach if you can help it. You
Mm,
know, um, definitely talk through it. So why don't we talk through it here and maybe even write some pseudocode of like what is the brute force approach to figure this out?
sure, let's
Just
go
maybe
ahead.
for yeah, yeah.
So, okay, so it looks like we know we're getting an array and we know we're getting the target sum. We have to go ahead, and the first thing that we must do, right, in a brute force approach to even see if there's any sum inside of the array, is to go through each element in the array. So that means that we would have to traverse the array. So I would say we would need to go ahead and whatever function or whatever way of traversing array it is, by the way, this is in JavaScript, you would go ahead and do that. So we would traverse array um, by, I'm assuming in here we would probably go by index, right? So that way we can add one to the index to get to the next element in the array. So I would say traverse array by index. How's that sound?
Cool.
Okay. And then once we traverse the array, so we start going through the array by index. I'm assuming these numbers may not be in order. I think that it would actually make sense to put them in order. I don't know if that if that's something that you thought about as well, right? So if you put them in order, you can start to eliminate, I guess, in a more optimal way, if certain numbers that are greater than that number may not add up to that, then you can start eliminating and stop the traversing of the array at that point.
That's a cool idea. That's a cool idea.
So you know what? We could actually want to sort that first. Sort array, traverse array by index. Now that you sorted the array is in order, you would want to go one by one, as I mentioned before. So in this case, -1 would be first. And then you kind of want to traverse the array once, but at that same time, stay on the first element while going, maybe having pointers,
Cool.
where the first pointer stays with the first element, and then the second pointer would go through each of the other parts of the array, and do math there, do logical math there to see if there is a target, if that math adds up to the target sum. So I
Right
would say
on. Yeah.
create pointers. One pointer will be on the first, or the would be the, I would say the, what is that, the sum element, like the one that we're gonna do all the math to. I don't know, on the, I guess, the target
Hmm.
element. Second pointer will be towards remaining numbers for sum. Cool. So I think at that point, once we have the pointers in place, we would do the math. And if at that very moment you get something that does equal that target sum, then unless the next number is the same, that we should exit that traverse and maybe go to the next, or not exit the traverse, but maybe put the second pointer to the first pointer to the second number, and then go from there. Because if their numbers are in order and you found one that hits, that means that the next number will be greater, will give you a greater target sum.
Yeah.
Okay,
Yeah.
cool. So I think at that point, what's the output? Oh, okay. So we also have to essentially, maybe before even sorting the array, we should probably create an empty array where we push the values from the pointers. So that way, whenever we find our sums, we'll be able to push it into that array, and that's what we're going to return.
Cool.
Okay, and then how many numbers can be in reverse order? Note that the target sum has to be obtained by summing two different integers in there. You can't add a single integer to itself. Okay, so they won't be, I guess, real numbers. You can assume that there will be at most one pair. So there's always going to be one pair. So that's good. So that means that once we find our pair, we can exit out completely, and we don't even have to keep pointing. Okay, that's good to know.
Yeah. And then what's the exit condition? Like what is going to cause you to return here?
Um, so I guess when you find the target sum itself, you would exit the condition itself, and then you would return that array. So you would exit. Well, if you find a target sum, you would push those numbers into the array, and then you would also exit out. At that point, you would return.
Cool.
Okay, so let me go ahead, and I guess we can start coding, right? So let's say we'll have
Well,
to
right before you start coding. So now you just walked me through kind of like the brute force approach. Is there anything you can do before you start writing code, thinking through this that might be so what would be the time complexity of this approach?
Okay, so I think that at the worst case, you still would have to go through each element in the array once, which would mean that it would be O of the length of the array, so O of n. So I think that this case would make it O of n, right? Because we're not traversing through the array multiple times. At most, we would traverse through it once.
Well, let's see. You sort the array, so that's at least
Oh,
one.
that's right.
Um, and then when you're traversing it the first time, you're going to figure out if the first index matches the next one and the next one and the next one, and eventually you'll find the pair. But let's say the first index doesn't add up to the target sum with any of the other ones. Like the very first number, the first element doesn't add up to the target. And in fact, I think in that sample input, that would be the case, right? That sample on the left, 3, isn't going to add up to 10 with any of the rest of the elements.
Right.
So then you've already gone through the loop once. You've already gone through the array once. Now you got to move that left pointer to 5. And you got to go through the whole array again, right?
Right.
So the time complexity here is what?
So, well, it's not. We're not nesting, so pretty bad with this one. So is it? It would be. Actually, I don't know.
I believe it's going to be n squared. Or is it n log n?
So if you
Now I'm questioning myself since we're on this stream. Let me see.
because if you eliminate, if you don't have to go through the first array, the first number again, and you subsequently don't have to go to the second number again once you go to the when you move the pointers, then you're
Mhm.
never going through the whole array essentially again, right?
That's true. That's true. It does go down each time. Yeah, since you can eliminate the portions before that, it's definitely going to be better than going through the whole array. But
Exactly, multiple times, right?
it's definitely, I guess the point is it's not O of n. We haven't found a solution that's O of n yet. It's definitely bigger than O of n.
Gotcha.
Um well, let's do the brute force approach here and then see if we can optimize it later. So let's go ahead and write out that for loop.
Perfect, perfect. Okay, so we're gonna go ahead and do let we'll say let target sum array equal empty. Then we're going to say let sorted array equal array. Now we can't just do a dot sort on this, right? Or can we? Would the dot sort
Yeah.
it that way? Okay.
Hmm.
So it's sorted in order. Okay, so now we're going to go ahead and I guess we can do a for loop here. So we'll do a for let x equal, or let I equal 0. We'll say while I is, I guess, less than array dot length. Right. So while the index, it's going to keep doing the for loop while the index is less than the array, the length of the array, correct? And then we're going to do I plus plus. And here we're going to go ahead and start doing the, right here we're going to have a pointer, right? So I guess the pointer should be determined, right? The pointer can't be here. Where would the pointer be? Let me see. So yeah, we have because if the pointer is here, then we're going to have to. Yeah, I think the pointers can be here, so we can say left or let first target equals I, or actually array of I, and then let second target equal array of I plus 1. Let's see. So now we're inside of the first element. We're sorted, so it should be -1. This one's going to be -1. The second one's going to be, I guess, at this point, it would be, oh, that's -4, then it'd be -1. So I guess we can say, well, once you finish that, then it's going to go to the next array. We don't want that to happen, right? So we don't want, so when the for loop is done and there's no target sum for that first target with the second target, we kind of want to keep the first target still to be that index without getting changed, correct? Okay, so then this for loop wouldn't possibly work because at all times we would not be changing that. At all times we're going to be changing that first number. So let's see, maybe a while loop would work actually.
Well, let's see. Why don't you keep it where it is, but think about what you need to do for that second target. So if you want that first target to stay the same and then you want to walk through the rest of the array, you should you've set the
Um,
first target. Yeah.
right. So okay, so I have my first target. I mean, we can definitely do an if condition here, right? So if this and that don't equal, then second target will go up
Yeah,
by one,
exactly.
right?
Yeah.
Um, but then it still has to keep. So then it's still right. So even if I do if first target plus second target um, does not equal target sum, then even if we just increase this one, it still is going to leave out of here and go to the next index, which would increase this one, right? We don't want that.
Right. We want to stay with that first target and keep it the same, and we want to walk through the next all the rest of the arrays until we find one that matches or we don't.
Hmm. Okay. Here I'm a little lost now. I think I'm. Yeah.
So we've set that first target, but before you set that second target, I think this is where you want to start looping through the rest of the array. So we may need one more loop in here.
And from there, now it becomes O of n squared.
Yes, yes.
Right. For I equals first target plus 1, where I is less than the array of the length of the array minus, at this point I think it would be minus the first target number, right? Because it would be the whole length of the length of the array is 1, 2, 3, 4, 5, 6, 7, 8. At this point, this would be 0 minus 1, and then I plus plus, and then right here we would have.
Yep. And now one quick small thing is like using I as your variable in the second loop.
A
lot of people, you might use J. A lot of people use J for a second one.
J, perfect. So now let second index equals array J plus 1. So now here if, okay, perfect. If first target plus second target does not equal to the thing, then we're going to up the second target, right? So second target plus 1. And then else we'll just return, or we'll push it, right? We'll push target sum dot push, and target sum array push. We would push first target, and we would push second target, and then we would return you would return out of this target sum, right? Yep, cool. I don't know. I don't know if this is gonna work, but I guess we'll walk through the logic, right? So we have empty array, we sorted array, we're going through the first element in the array. We set up that first element as the first target, first pointer. Once we have the first pointer, we're going to go through now every other element in the array, which would be the second one. We'll go into the length of the array is -1 because we don't want to hit that length. J plus plus, and then we're going to set the second target as the second number there. And then we're going to say if those two numbers do not equal, then we're going to add target sum +1, which would make this go up now, right? And then if it is, we'll push both of these and then return the target sum array.
A couple things before you run it. There's a couple syntax types things, like check line 15. J just needs to be initialized.
Yes.
And then on line 18, take a look at that line. Do you want to add one to second target? Second target is the actual element in the array.
Oh, yes, you're right. So it would be J plus 1. Wait.
Yeah, and you get that for free with the for loop.
That's right. So we don't need this if condition here then.
I think you need an if condition, and it was almost the one that you wrote, but I think
Right. So
it's
if the target sum if the target plus the first target is equal to this, then we're going to return.
yeah.
Alrighty. So then we are going to. Can we just do a quick return here like this?
Mm-hmm. Yep. Well, you can't return.
You can't return the push, right? So
You could return a new array right there if you just want to just pop those two things in the array in a new array that you create. You don't have to like add it to that target sum array, or you could do that. Yeah, that's perfectly fine. Yep.
Gotcha.
All right. So let's see. So we're going to walk through the whole array, and we're going to check every element in the array, and for each element in the array, we're going to walk through the whole array starting at the beginning, or actually starting at that target, right? First target.
Right.
One quick thing. Take a look at line 15 where you say we're letting j equal first target plus 1.
That makes sense. Okay, so this would. Can this just be? Yeah, because this is also first target wouldn't make sense, right? That's the number plus 1. Would it just be I
Mm-hmm.
plus 1 at this point? Yeah.
Yeah, that's cool. And like for people listening, like if anybody's watching, first of all, it takes a lot of like courage to go on here and live code when you don't know the solution. So Kevin, like props, like this takes some courage. And secondly, like the conversation that me and Kevin are having is the more important thing. If this was an interview, like the fact that we're able to go back and forth and figure out bugs and talk through bugs, and I can say one thing and Kevin understands what I'm saying and he fixes it. That's what's important. Like it's way more important than if this, when he clicks run, if this works or doesn't work, matters way less to me as an interviewer than the fact that we were able to communicate calmly and like understand each other for the past 10 minutes. Like that's what matters to me. So I actually don't even care if this works. I care a lot more about the fact that we just had a good conversation about this code. You know, do you see it the same way, Kevin?
Yeah, I agree. I definitely agree. I think that when we're interviewing people, I think that's what the main thing we're looking at is like the conversation, the questions, and can he or she pivot, if
Yeah.
there's any feedback given.
Yeah. Okay, so let's see what we get here.
Oh. What is it missing? Oh, there you go. is not a function. Array dot length is not a function. Is that not a function? Now
No,
oh,
that's just
it's
a property. Yeah.
yeah.
Let's take out those function calls. Yep. Cool.
Oh, okay. Do we fail the case? We got undefined here.
Test case 1 passed. Hey.
Yes, yes.
All
Reverse, reverse. Okay.
right, so test case 2 failed. So the array is 4 and 6. Let's figure out why that failed.
Oh, where's the array actually? Oh, the array is 4 to 6. Okay. Why did it fail? So,
Or sorry, not the array is 4 to 6. The expected output is 4 to 6.
right. Where do we see the array? Maybe we
I don't know if it tells you. It might not tell you.
make
But we can kind of figure that out.
probably print it out.
Let's see. Let's imagine that the array is just 4 and 6. Like the original array is just 2 elements, 4 and 6. Would your code find those two and return them? Let's see, we check the first
Let's see.
target. And then we go to the next target. And as long as it's less than the length, -1, and we set. So just take a look at line 16. I don't know, this is a pretty tricky bug.
Oh, because it's already there. So
Yeah.
second target should just be J already.
Yes, yes.
Yeah, second target should just be J.
All right, let's see what happens now. All right, so we got another one pass, right? Wasn't there one more that passed now? Test case 1 passed. Test case 3 passed. Okay, cool.
Okay, cool.
Now let's see. We returned undefined. So in what situation would we return undefined here?
If it doesn't finish, or if it doesn't find, let's see. First target, okay.
The question is worded kind of tricky because that last sentence in the question says you can assume there will be at most one pair of numbers summing up the target sum, but reading that carefully, it means there could be none, right? There could be no pairs. It's just saying that at most there will be one, but there could be no pairs that add up. And in that situation, what would you return if there are none?
You would return nothing.
And what did it ask you to return if there was not a match?
Let's see. It should return an empty array. So at this point, if it gets out of this for loop right here, right? If it comes out of here, then we would just always return.
Cool. Let's see what we got.
Still failing. I think oh, there you go. Okay, now, but they're still not finding anything, which is weird, right?
Cool. Did we get any others pass? I'm just curious. Let's see.
Let's see.
Test 1 passed.
Oh,
Yeah.
I just
There we
these
go.
two. Okay, so something's going on
Cool.
with these two. Okay.
All right. So let's see. Okay. Online, do you have anything?
I'm looking right now because I'm thinking that something here, right? If it knows it's there, but then target some second array would be that just because for shorthand, and it would go +1, so we go to the next one. Could it not? Maybe it's not finishing.
Yeah. That's exactly what I was thinking because we don't want length -1 if it's less than. We would want -1 if it was less than or equal to, I
Equal
think.
to.
Okay, yeah, let's see what we get
There you
here.
go.
Hey, all the test cases passed. That's what's up. Okay, so that was brute force, right? And just one more time, like the time complexity here is definitely now what?
Oh, 2 n squared. N squared for
Yeah,
sure.
of n squared. Um, so is there any way that you don't have to implement this, but is there any way you could see to maybe make this more optimized? There, I'll just tell you there is a solution here that is O of n.
Yeah, I think I know it too. I think it would be the wild loop. I think with a while loop, you can essentially keep going without having to exit the while loop. And I think that you would put the pointers outside. So you would set the pointers to an integer like 0 and then 0 plus 1 on the outside of scope. And then inside the
Mhm.
wild loop, you would go ahead, use those pointers. And if those pointers sum up, then you would return another while loop. If not, then you would increase you would increase a second one by 1 um, until the length of the first pointer is at the length of the array.
Uh-huh.
Yes. So then essentially itself, it would continue running the whole array, but always moving the second pointer if there's no sum equal to it. Does that make sense? But that only work if it sorts.
Yeah, yeah. That would only work if it's sorted, that's right. But I think that's maybe called the two number plus or two number two is when you have a sorted array. There's like another one that's like that. But the pointers is the trick. Like the two pointers is the trick. I think they call it sliding window, I believe is the
Um,
pattern.
okay.
And you just want to have a left pointer and a right pointer. And you want to slowly but surely like slide that window in so that you can figure out like, okay, well, let's move the left pointer up and the right pointer over until we've checked everything in the array
Yeah,
if it's sorted.
I think we can do this real quick actually. Left pointer is equal to 0. Let let right pointer equal left pointer plus 1. And then here while array left pointer is less than array dot length, right? Or actually it's just left pointer.
Mm-hmm.
Left pointer. Then here we would go ahead and say if array left pointer plus array right pointer is equal to target sum, then we would go ahead. Do we have this here? Oh, let's uncomment this out. And then we would say go ahead and do the same thing that we did here. Right, so we would do the target sum array, push both those into there. If not, we would do right pointer plus plus or just plus plus. So that will keep going up plus 1. But then we also have to increase the left pointer. And so this actually might have to go inside of here or else right pointer plus 1. And then outside of it, we would then increase the left pointer plus plus. So if not, oh, actually, it would always come back out of here. So wait, there's something wrong here. I'm on the right track here. I'm just now trying to understand, right? So if
Yeah, you're on the right track.
else right pointer plus plus, so then it exits there, and left pointer is still the same. Well, we would set we don't want to increase the left pointer, right? Huh. Huh. Okay. Let me see. Let me see. No, I'm a little lost here now.
Yeah, like so you do want, first of all, use the sorted array instead of the array they gave you, since we're going to do the sorted version of this.
Ah, yes, that's right.
And yeah, cool. And then we want to start with the left pointer at the lowest value on the left, but the right pointer, since the array is sorted, what if we started all the way at the end? Instead of starting with one element right above it, what if we started all the way at the end, the highest value? And we know that, like, first of all, if the highest value is
So
higher than our target sum, we could just skip that right away. We can just knock that out because we know that, like, if it's higher than the target sum, we definitely can't add it to something. I guess I take that back because they can have negative numbers here, so I take that back. Like it could be so, but yeah, if we started at both ends and worked our way towards the middle,
right.
then at some point, like, you should find those two. If they're sorted, you should find the two numbers that add without having to go through the array again. Yeah.
Gotcha. So then the logic changes completely, right? So then if sorted array plus right pointer equals target sum, then we push it else, we would okay, then so it would be an else if, and then it would essentially be else the if this is less than, let's see. Perfect. So if this right here is less than, or if it's greater than the target sum, then we know that the number towards the right should decrease because that's the bigger number.
Mm-hmm.
So then we would do right pointer minus minus.
Mm-hmm.
Else if oh wait, there you go. Else if it's less than, then we would increase the left pointer, right? Yes. And if not, we'll just return an empty array. So,
I guess you could you return the target sum array either way here. It's going to be start as an empty
oh,
array and
that's true. Yeah, because it's going to return out of this anyway. So I guess going through the logic again, we're always going to have a pointer at 0 when we start, and then the end, which is going to be array. It can be sort of array. So this is, yeah, the same thing. Length minus 1, so that's going to give me the last integer. And then right here, we're going to go through while left pointer is less than the sorted array dot length. Now we're going to say if the sorted array left pointer plus the one on all the way to the end is equal, then we'll return right away. If not, we're going to if that sum is greater, that means that the right pointer might be the bigger number, so we're going to decrease by 1. So right pointer decreases by 1. At that point in time, we exit out, and now we're minus 1, so this stays at 0. This now goes down 1. We do the same thing again. No, if we see that this is greater or less, then it goes, and then whatever. Okay, this makes sense.
let's see what happens here.
Oh, is it out of resources?
Yeah. So those else ifs, there's a chance that we won't increment, or go ahead. You look through this.
Let me see. There's a chance that we won't. Um, why? Because it's the left pointer can also be greater than or equal to length. No, it can't be
Well,
greater.
that left pointer, the while loop is only going to exit if the left pointer makes it to be you know, equal to the length of the array. And since it's nested here inside this else if, it's only going to be incremented in that situation. But I think we want to increment it if none of those, like always, basically, every time that while loop runs, we want to increment it just so that the while loop is guaranteed to end at some point.
Okay. So, but what? Okay, so what if it hits this thing here? Do we also increment both?
Well, let's first try just pulling out that left pointer or like removing that last else if
Okay.
and just put the left pointer plus plus right there so that we always increment it. And then let's see what we get because I do think we can still like we still might see some issues here. Let's see.
First target is not defined. What's first target? Oh, first target. Oh, left pointer.
Oh yeah, we never actually set our targets there or instead of targets like the values of see how you have did the if statement is using sorted array left pointer, but we're not saving that anywhere.
Oh, that's right. Okay. We should put that somewhere. Let's say let, I guess we'll call it first target.
Yeah.
Let second target equals. Perfect. So now we can just do this. There you go.
Cool. And then there's just a need a closing bracket on that line 29.
Line 29.
Okay, cool.
And this is second target. Cool. Should we run it?
Yep, let's run it. Okay, test case 2 passed. What other test cases passed? Yeah, a bunch of our test cases passed.
Let's see.
4, 5. Cool. Awesome. So let's see. Right now, we are still at O of n, right?
Yes.
Cool. So we're almost there. Let's go look at one of the ones that failed. Let's see. 11 and -1 is what it expected. So let's look at what that sample input on the left would do, where they have that array that they've given you. Like what would happen there?
Right. So then it would be -4 and 11. Um, so it doesn't equal each other. So then it would right pointer would go down. So this would now
Hmm.
be 8.
Yeah.
And -4 would go up to -1.
Yeah.
1 plus 8 equals 9. 1 plus 9, yeah, 9. So that doesn't equal. So then it goes down 1 to 5 and up 1 to 3. And that's 8. So off the jump, when we missed out on 10 because I think at that point, yeah.
Yeah. Yep. Because we need to check if if 11 and -1 get added together, but we're never doing that. We're only looking at -4 and 11, and then we move both of them.
You think the left pointer needs to go back now into like the
Oh, let me think here. Let me think. And I should say, like, we aren't looking at the solution to this at this point in practice. Like, if I were practicing, I think this would be a good time to say, like, we made it really far. Like, we have a pretty close solution with half of our tests passing at O of n. We're probably just banging our head against the wall unnecessarily to try to figure this out. But just for the fun of it, let's see if we can. But I wouldn't be like opposed to looking at a solution at this point. I mean, we really have worked through most of this.
yeah.
Um, but let's just see if we can put a few more minutes into it. Um, so let's see. We only decrement the right pointer if you add it together and it's greater than the target sum,
Wait,
right?
I do think that the else if might work now. It was before
Uh
it
huh.
was because the target wasn't they weren't defined, so it probably didn't know where it was going.
Yeah.
I think at this point we might benefit from doing the way we had it here.
Cool. Cool.
Right, I think so. Let's see. Oh, still no. Still running out of resources. Okay, I wonder why.
So the first one, like left pointer sometimes isn't going to get incremented, and then the while loop will just run forever. You know?
Oh, wait. So let's actually see that because right. So if it's -1 and sorry, -4 and 11, it doesn't work. Oh, but is it greater? Negative 4 and 11 gives us not 9,
7, yeah.
7. So it's not greater than. So it's less than, right? So it goes into here. Else if first target plus target is greater than, no, less than. So then left pointer goes up. So left pointer now goes up to -1. So at that point, -1 plus 11 should equal 10. So it should come out, right? Am I seeing this wrong here? Left pointer would be -4, and second target is 11. -4 plus 11 is less than target sum, which is 10. No?
Sorry, I zoned out. So let's see if the if first target plus second target is less than, which it should be in this point, left target should go to the next one only, and so then it would be at -1, but right pointer should still be at 11,
Right.
and so then they should match. Yeah, so I think that the first that test case should pass. I think.
But it
Or,
doesn't. It goes out of resources.
does it show you sometimes if like test case 7? Like some of them might have passed, but others don't. Is that possible?
I don't,
Does it tell you?
it doesn't tell me.
Okay. Let's see, because there are other examples, like other arrays where you wouldn't get that left pointer incremented
Right.
enough. You know.
Right. So strange though.
Let's see an example here. If it's less than the sum, we only want to do the left pointer and the right pointer. Yeah, I think I think I think it's probably worth looking at a solution real fast and seeing where we what we missed, and like I'm sure there's some like small tricks. So
So we did the first one.
yeah, there's the first one. Okay, so we are doing a for loop through the array.
Oh, it did an object.
So they subtract the current number and they say, is that current number in the array? So like, okay, so you can see what they're doing on line 7 there. They're figuring out, well, let's just look at what number would we have to add to the current element in order to equal the target sum.
And if it's there, it's there.
And then they're like, oh, well, let's just look through the array and see if we can find it.
Clever.
Um, I don't know if that is, I guess
Oh,
I'm questioning if that's O of N. Uh,
this is the one.
yeah, here's our left and right pointer. Let's see what we missed on this one. So yeah, it looks like you were so close. Like we were so close on this. Right minus minus if it's greater than, right minus minus if it's greater than, left plus plus if it's less than. Yep, we did that.
Oh, look at this. Left is, oh, they're measuring once this thing is done here.
While left is less than right, so that it never like,
It coincides.
uh-huh.
Because that's
So try it. Let's try that. Let's just change that.
oh my gosh. It looks so similar too.
I mean, really, like it was right there. So let's see, left is less than right. Let's
Oh,
see.
what's the feeling?
Okay, but a bunch of them passed here.
Yeah, a bunch of them pass actually. Let me see. Yeah. Actually, yeah, literally a bunch of them pass.
Now, is there anything for the reason why they had the else if in the order that they did? I'm trying to think. Return target sum array. The right is length -1, left is 0. Oh, they did sort it. They did sort it just like you did.
Yeah, we sorted it. Yep, yep.
Return current sum.
Same thing. What's going on here? It's so weird.
The only difference I can see is that the sort, they return a sort function. And like in JavaScript, if you sort strings, I'm sorry, if you sort numbers, they get sorted as strings, which is weird.
Oh,
So,
so
so you might need to pass a sort function in
so I
there.
would have to do the locale.
You can just do, yeah, basically what they did since they have the example. But like you just have to tell JavaScript how to sort it rather than letting it do
Wow.
it.
Good old job.
All right, cool. So that's O of N, but I still want to point out that like it's not exactly the most efficient because you have to sort it first. You know? I'm surprised that these are I think there is actually a different solution here that doesn't require you to sort it first, but maybe not. Maybe I'm just wrong. But anyway, this was good. Like we almost got it. Like we were this close to having it.
Yep, this was fun. This was fun.
Well, good stuff, man. Thanks for doing that. Maybe we can do this again.
Yeah, that sounds good to me.
Cool. All right, thanks, Kevin. I hope you enjoyed that and got something out of it. Please leave a comment and let me know what you thought. I'd love to make these more valuable for you, and thanks for watching.